Okay, so as I'm sure you've guessed, this video is about finding the inverse of a matrix, and this is, in my opinion, the easiest way to find the inverse of a matrix. So let's say we have a matrix that's like 7, 5, -3, 2, 0, 1, -1, 4, 6. -6, sure. It's just a random matrix. And we want to find the inverse of this. The easiest way is to use the adjoint or adjugate matrix. And how we do this is we're first going to find the submatrix, or I guess the matrix of cofactors for each of these terms. And so what that means is 7 right here is the first term. It's in the first column and the first row. So submatrix of 7, which is the first column, first row, is going to be what we get when we cross out the column in the row that 7 is in. And as you can see, we're left with 0, 1, 4, -6. So this, for example, would be the submatrix for this term. And we're basically going to find this matrix for every single term excuse me, in here. So for 7, we already have it. It's 0, 1, 4, -6. Let's find the 1 for 5. When you cross those out, we get 2, 1, -1, -6. But we got to be careful with one thing, because whenever we find this matrix, which is called the matrix of cofactors, we have to be careful about the signs. It's like when you're finding the determinant and your signs alternate. It's like that. We have to make sure that all of these little mini determinants in here, the submatrices, they all alternate. So that's positive, that's negative, this is positive. We cross these out. We're left with 2, 0, -1, 4. This is negative, and we cross these out. We get 5, -3, 4, -6. And this is 7, -3, -1, -6, because this is 0, and this is -7, 5, -1, 4, oops, -1, 4, this is 5, -3, 0, 1, this is 7, -3, 2, 1. Yes, I know this is a little tedious, but really, like, once you get the hang of it, it really doesn't take that long. So here we have it. Now we have all of our nice little determinants, our 2x2 determinants that are actually not like super time consuming to take. Hopefully by now you know how to take a 2x2 determinant. You just take the product of the main diagonal and you subtract the product of the other diagonal. So in this case it'd be 0 times -6 minus 4. So that's 0 minus 4 is -4. In this case it's -12 minus -1. So that's -11. But this right here means that we have to switch the sign to +11. The next one is 8 minus 0, which is just 8. See how convenient it was to put that 0 in the middle? Then we have 30 plus 12, well, rather 30 minus -12, but that's, -30 plus 12. So that's -18, but there's a negative sign, so it's +18. And then it's -42 minus 3, so that's -45, then it's -5, so that's, right here we're going to have -33, and then this is just 5, thank goodness. And this is -13, and then we have -10. Okay? Alright, so this right here, this is our matrix of cofactors, which is important. You should probably know that, because, you know, they might ask you that as a question, like, can you find the matrix of cofactors of this? And now all we have to do to find the adjoint or adjugate matrix is take the transpose of the matrix of cofactors. So the matrix of cofactors, and when you take the transpose of that, that's equal to the adjoint, or otherwise known as adjugate matrix, which is what I'll show you right now. And so this, we're just transposing it, which means we kind of reflect it, we reflect it over the main diagonal. So all of our rows become columns and our columns become the corresponding rows. So for example, -4, 11, 8. That's our first row. And now it's going to become our first column. And we just keep going on like that. Alright, so this right here, that's our adjoint matrix. And I know I was like, oh, at least we're not going to have to take that long determinant, but now we're going to need to take that long determinant because our inverse matrix is the adjoint matrix times the reciprocal of the determinant. So let's just find the determinant real quick. It should be a breeze after, you know, what we just did. And so remember, when you take the determinant of a 3 by 3, you just cross out the corresponding row and column just like we did before, and then we take the determinant of the submatrix, and then we also alternate signs just like we did before. Oh, plus -3, which is again just -3, so 2, 0, -1, 4. If you don't know how to take the determinant of a 3 by 3 matrix, you probably learned that before watching this video. So maybe, yeah, go learn that because that is important. So this will be 7 times 0 minus 4, which is nice, minus 5, and then -11, minus 3, 8. So we got -28 plus 55 minus 24. Okay, that worked out well. So this ends up being 3. Our determinant is, thank God, a nice number. And so this adjoint matrix times the reciprocal of the determinant is going to be our inverse matrix. So we got -4/3, 18 over 3, which is 6, 5/3, 11 over 3, -15. Oh, this is working out nice. Kind of, pretty much. I mean, better than I expected. So this right here, this is our inverse matrix. And if you wanted to double check that it's our inverse matrix, you could multiply it by our original matrix and you would get the identity matrix. But I've had enough. I'm not showing you that. If you want to try it yourself, be my guest. But yes, this is how you find the inverse matrix using the adjugate matrix method.